Let's solve another interesting question. As you see, one block is placed on another block, and that is also tied with a string. And we are applying the 45 newtons of force on the lower block. And in this question, we have to draw free body diagram for every block, as well as we have to identify what are the action and reaction forces. Means we will revise Newton's third law and we will see what forces are action and reaction pair of each other. And secondly, we have to find out the tension in the string as well as the magnitude of acceleration. So that's a detailed question. Let's start. So what is a free body diagram? In which we draw all the possible forces exerted on an object. So we will start from this block 5 kg. All right. So I'm going to draw its free body diagram. All right. So I'm saying, first of all, I will draw the rectangular coordinate system for this. So free body diagram of the small m. All right. Let's say this is small m, and this is a capital M. All right. So we say that the one force is exerted by the larger mass or the lower block on the upper block. So that must be this arrow. All right. So if we write it normal force Fn, and the second vector that is exactly same in magnitude but opposite in direction, but that's not a reaction pair. All right. Remember that. So this is the weight mg. The third force must be in this direction, and you can identify this should be the force of tension Ft. All right. So is there a force of friction? So yes, this is a force of friction because they say in the question that the coefficient of kinetic friction or the dynamic friction between all moving surfaces is 0.200. All right. It means that not only the two blocks have their own force of friction, but also the there is a force of friction between the lower block and the ground. All right. So right now, just imagine, because we are not applying 45 newton of force on the upper block or the smaller block. So when you are pulling the lower block to the right side, just imagine in which possible direction the smaller block can slide. Due to inertia, because inertia is a property of matter that always keep its state of motion. If it is at rest, it will remain at rest. All right. So if you are trying to pull the lower block to the right, so the upper block can slide to the left. All right. Now to avoid this sliding phenomena, the force of friction must be in opposite direction of force of tension. And right now I would say that this force of friction is same in magnitude as of force of tension. Why is that? Because the smaller block is in equilibrium. So can we calculate its magnitude? And moreover, right now I am writing this force of friction because this is applied by the larger block, or I can say M on small m. All right. And this will be the same force that will be applied by the smaller block on the larger block. Then I will write it M on capital M. All right. So these two forces are actually action and reaction pair. Okay. According to Newton's third law. So can we calculate this force magnitude? All right. Yes, we can calculate this force magnitude because this is the coefficient of friction. All right, mu. Right now they are saying kinetic friction, so mu k and normal force Fn. So what is its value? That is 0.200 times the mass is 5 kilogram times g is 9.8. So this is 9.8 Newton. Now remember I told you that the upper block is not moving because it is tied with string. So that's why in the free body diagram we have drawn the same length of these two right and left arrows. On this basis, can I say that the force of tension is in fact 9.8 Newton? Very easy. All right. Now let's find out acceleration in the lower block. And its free body diagram is very interesting because you will see lot of forces exerted on the lower block. So this is our system in this case if we are drawing its free body diagram. Okay, now let's now discuss the free body diagram of the larger mass. So this is the mass, and this, first of all, we will draw this larger force exerted on this block, that is 45 Newton, as you see also in the question, which is actually accelerating. And what are the other forces? The one force that I must draw here downward is the force exerted by, that is mg, right? Remember, small mg is the force due to the weight of the upper block, whereas the another force, but now this a longer arrow is representing the capital mg, is the weight of the lower block. And if you sum these two collectively is equals to the normal force. Which normal force? The force exerted by the surface on the upper block, which must be, we should represent in the free body diagram by the longest arrow. And this is the force which is in fact equals to mg plus capital mg. All right. What are the other two forces that you should not miss in this diagram? The one is the force that is the force of friction. You remember I told you this is the force which is applied in this direction. Okay, and the one force that is applied in this direction also. These two forces are force of friction. So let me explain you. This smaller arrow, the red arrow, is representing the force of friction applied by small m on big M. All right. Okay, because this is on the left side, whereas this force is on the right side. Both are action and reaction pair. Whereas this force is also the force of friction, which is applied by the ground. Okay, ground on the big M. All right, which is in this direction. You understand? The one force is in this direction. Okay. So how many forces total are exerted on the 10 kg? So 1, 2, 3, 4, 5, 6 forces. So if you see along y-axis, so we see the three forces are balancing each other. All right. So we can write an equation that the normal force Fn prime is equals to mg plus capital Mg. Okay. What about the forces along x-axis? So this 10 kg is accelerating in this direction, which means that the 45 Newton force must be greater than the sum of these two frictional forces. All right. So what I mean to say that the resultant force, the net force, must be 45 Newton minus the one force friction which is applied by, you remember what I told you, M on capital M, the upper block on smaller block or on the lower block, minus the one force of friction applied by ground on the lower block, because we cannot ignore the roughness of the ground as well. Okay, so ground on the lower block is equals to capital MA. So basically, if you see that this is the resultant force F net. According to Newton's second law, we say F net is equals to MA. So I have written the equation of F net, the resultant force. Okay, now, interestingly, we had already calculated the force of friction. You see here, this is a force of friction, 9.8 Newtons, right? So this is the force, small mass on larger mass. All right, and we had already calculated its value, which is how much? 45 minus 9.8 Newton. Okay, minus, what is a force? This is also a force of friction. All right, and what is a general formula of the force of friction? That is mu, in this case mu d Fn prime. Okay, mu d Fn prime, the coefficient of friction, times the normal force. What is a coefficient of friction? That is 0.200 times what is a normal force? That I had already told you that this is the sum of the weights Okay, you see along the y-axis, these forces are balanced. Okay, so that's why I will write here the weight. The upper block has a weight 5 times 9.8, whereas the lower block has a weight 10 times 9.8. Collectively, this force of friction is. So interestingly, this is 29.4 Newton is the force of friction applied by ground on the 10 kilogram. So if we put its value in the equation, 29.4 is equals to the mass of the lower block, that is 10 times A. So we can now solve very easily what will be A. So A is 0.58 meter per second square. So this is the verified answer. Acceleration is 0.58. So we see that this, with this acceleration, the lower block will slide, whereas the upper block will remain at the same position. All right, I hope you understand this question.